So what we had discussed yesterday, so we discussed about a network. What is network? What is networking? What is internetwork? What is internetworking? Connection of two or more devices. Interconnection of two or more devices is called network. Okay. Interconnection of two or more devices is called a network. Okay. Next one is yeah, it's a communication between interconnected devices called a networking. Okay. So what is another one? Internetworking. It is a connection of two or internetwork connection of two or more networks. Internetworking means communication between different networks. Different type of networks based on the geographical range or a size, local area network, campus area network, metropolitan area network, wide area network. So your local area network within the room, or it can be a within the floor, or maybe it can be a within the building. So that is the maximum within the building is maximum size of a single LAN network. In case your network size is around a very big size, but within the campus, multiple buildings are in the campus, but all these LANs are connected together and become a very big single network, but within the campus. Metropolitan area network, so that is within the city. It is also a very big network compared to campus area network, but within the city. W and wide area network. It is a global network. It is a networks of network. It is entire global range. It is so different geographical locations we can able to communicate through WAN network. So where are we? Yeah. Of course, some other words also came, PAN, HAN kind of stuff. Okay. Intranet and internet. Of course, someone asked me yesterday, extranet also. Intranet means within the local, so your private network only. Okay. Internet means it's a global network, it is a public network. But extranet is a private network, but not local. Okay. That is a extranet. It is a private. So my network is my network, your network is network, but we are in the private. It is not public. No other people can able to access. It is within the private. And also we discussed about what is a default gateway when you are communicating from one PC to another PC within the local network. We don't require a default gateway. But when you are communicating outside of your network, you have to send your packet through default gateway only. So in our networks, the router is act like a default gateway. Okay. And what is the default gateway? IP address. It is our router IP address. Okay. And there is a few more things we have to discuss. That is what is NIC, network interface card. Any device in the network, any device want to connect it to. So where it is? Any device that want to connect. No, wrong. Any device that wants to connect in the network, that device need a that device need a NIC. Any device that wants to connect, any device wants to connect in the network, the device need a NIC. Okay, the NIC can be wired type or wireless type of NIC to connect. Depends upon your type of network, wired network or wireless network it is. Okay, some are mixture is also there. Okay, so every NIC, so that is NIC part. So this is wired NIC, this is wired NIC. Sometimes we have to insert into your desktop or a server. Sometimes it is on motherboard, built in on motherboard. So this is a NIC card, LAN card, Ethernet card. There is a port to connect to the network. Okay, there is a port called Ethernet port or LAN port. LAN port. Okay. So these Ethernets are three different types are there. Ethernet, initially Ethernets are came into market, that is 10 Mbps support, and fast Ethernet is 100 Mbps, gigabit Ethernet is 1000 Mbps speed or a 1 Gbps speed. Gigabit Ethernet. Okay. So different wireless NICs also available with a different type of labeling on it. Yesterday, I think so. I told you to watch what is the difference between 2.4 gigahertz to 5 gigahertz processor. Okay. So about NIC, guys, NIC either it is a wired NIC or wireless NIC. It has a MAC address. The MAC address is called media access control, also called as a physical address or a hardware address. This MAC address is given by manufacturer of NIC. We cannot change the MAC address. Okay, we can change IP address, but we cannot change the MAC address. There is a MAC spoofing is possible, means duplicating MAC address. MAC binding is possible, means okay, MAC binding is possible. Already I explained for a Wi-Fi network security, we do MAC binding. So whenever we are trying to connect to the wireless network, so when you use the name and password automatically, so your Wi-Fi router or wireless access point check your MAC address. If MAC address is listed in yellow list, you are allowed to access. If MAC address is not in the yellow list, you cannot able to connect. Okay, this MAC address is 48-bit in number, represented in hexadecimal. This is a very important point, sir. These two. Okay, and what is the 3 points? Okay, important points. Of course, we can't change the MAC address. To check the MAC address, get MAC IP config space slash all, or you can go to ncpa.cpl, double click on your NIC details, you'll find a physical address. And also we discussed about the networking cables, coaxial cable, twisted pair cable, fiber optical cables kind of stuff. Coaxial cables are a single copper wire is in the center which transmit our signal. Okay, data is transmitted through the center copper wire only, which is surrounded by insulator, and that is surrounded by a copper mesh. Why copper mesh? Copper mesh is used to protect your signal from electromagnetic interference, which causes the crosstalk. What is a crosstalk? It is a mixture of signals. This coaxial cable support up to 800 meters with a different type of connectivity. Okay, so up next one is twisted pair cables. So pair of cables are twist each other here, and there is a totally in generally it is a total 8 wires. It is also called as a 4-pair cables. In this twisted pair cable, we have a UTP and STP, unshielded twisted pair cable and shielded twisted pair cable. Why twist? Number of twists increases, the attenuation decreases, data transmission speed increases. and whatever it is, there is a copper mesh on it, so to protect from electromagnetic interference. And these wires are used, we use a RJ45 connectors to connect these wires. Okay, so this is a basically our LAN wires, LAN cable it is. We are generally using LAN cables, UTP or STP cables we are using RJ45 connector to connect this cable. Of course, it is a 4-pair cable, 8 wires are there. Out of 8 wires, 4 wires are blue, orange, green, brown. Remaining 4 are a combination of white and these colors, like a white, blue, white, orange, white, green, white, brown. RJ means registered jack. Different cables are there, guys. The cables in the categories, different categories will provide a different type of speed limits. But whatever it is, maximum 100 meters distance only it will support. This is called a patch cable or a LAN cable. So we can see both ends RJ45 connectors to connect your devices. When you are connecting different devices, so different type of cables also use same cable, look like a same cable, but different way of connectivity is there, straight through, crossover, rollover kind of stuff. But now to create this type of cables manually, like we use this crimping tool. So we insert these wires into this RJ45 connector and press with this crimping tool, then the cable will be created. Once cable is created, you have to test it, make sure that cable is working or not. Okay, if cable is not working properly, what to do? Use the testing tool. Cable tester is there, so you have to use this tester to test it. Next is optical fiber cable, made up of glass. The optical fiber cable is nothing but a made up of glass. No metals used in this optical fiber cable. No electromagnetic interference. Okay, so in copper cables we use electrical signal. Here we use light waves. And what is the advantage of fiber optic cable? Very long distance communication, very high speed data transmission is possible. Okay, normally our UTP, STP having 100 meters distance limit is there, but fiber optical cable will support a much longer than 100 meters. We don't use in a regular LAN communication. Already I told yesterday what is it? Because of the cable cost may lower, but compared to that overall cost it will increases, because you need your devices, your laptop or desktop is required fiber optical connectivity, and the cables and the switches and routers, so that is become overall cost will increases. It is cheaper as well as a costly, because it is cheaper, the manufacturing cost of that cable is cheaper, but remaining equipment is become costly, the overall cost increases. Plus based on usage it is much cheaper and as well as a costly. Means if I am using for my LAN communication, it is very costly. If I am using in my server side or network side, core network side, so what happen, lot of data transmission is required, there it is become very useful. And we are all getting internet through optical fiber cables only. So there is a submarine cables are there. So through that one, country to country, continent to continent connection, through that one only we are getting it. Okay, not with the satellite part. Yesterday I stopped at this one, right? Physical topology. What is that noise? Okay, physical topologies, that is we are discussed yesterday. So just give me 1 minute, I will have wash my hands and come back. We'll discuss this thing. So physical topology, the way of devices connected physically called a network, right? So that is a physical topology. You are connecting devices, so how you connect devices, based on that it is a physical topology. Logical topology based on the IP address configurations. Okay, It is logically same network, different network. We can decide by IP address configuration only. Different physical topologies are there. So right, bus topology, ring topology, mesh topology, star topology, point-to-point topology, point-to-multi-point topology, hybrid topology kind of stuff. Okay, 1 second. I got a full cold. Able to find anything. Okay. Sorry. I will try to draw these things in this screen. Okay, so this is a that is enough, I think so. But it will become a very big picture. So this is a backbone cable, guys. Are you able to see the screen, guys?
Yes, sir.
Yes, sir. Sir.
Okay. So this is the backbone cable. Okay. This is the backbone cable. So PCs are connected to this backbone cable directly. All are communicating through backbone cable. It is a volt style cable TV type. So there is a cable and all TVs are connected to that cable only. Okay. So okay. So here it is. Example, this is a PC. Yeah. PCB, PCC. Okay. So this is a bus topology. So we had to write somewhere. What is this? It is a bus topology. It is a very simple to configure. It is very simple to configure, and yeah, but a very less cost. Very simple configure, less complex. It is very simple one. This very simple cable connect to the cable only. But there is a certain problems are there. If this backbone cable broken at any place, the further communication will be stopped. Okay, or yeah, that is, and it is very difficult to troubleshoot also, because you have to trace entire cable where is the breakage is occur. You have to find it, you have to fix it. Sometimes it is not flexible also. So this is called a bus topology. Next topology is, see, next topology, there is a PCs. So it is a paintbrush is always best. You happily put it anything, anywhere kind of stuff. It is PCs are here like this. Better move this place because we need another some more place. Okay, so the point is each PC is connected to another PC. No, no, no. We should not say like this. One PC is connected to another PC, and one PC is connected to another PC. Like that. Next PC. One PC is connected to the next PC. The next PC is connected to another next PC. Finally, last PC is connected to the first PC. Finally, last PC is connected to the first PC. Okay. Here, if you write like this, guys, PCA, PCB, PCB, okay. So it is works based on the algorithm. For example, you want to communicate from A to D. You have to communicate from A to D means is actually had to communicate like this: A, B, C, D. You want to communicate D to A, D, E, A. Exactly. Now we have a chance to this sense. I will remove these things. I'll put arrows. Arrows are much easy to understandable. So arrow, or like this also no problem. Hmm? Okay. So like this, each PC is connected to another PC. It form a ring, either a clockwise ring or an anti-clockwise ring. So it form a ring. Okay. So this is called a ring topology. It is also very easy to configure, but it works based on the ring topology algorithms. It is difficult to scalable. If you want to add one more, again you have to configure one more. If you add one more PC, again you have to configure everything. Okay. And next one is, if any one of the device is down, if any one of the device is down, if any one of the device is down, again big problem. Okay, because the further communication will be stopped. So for example, PCC is down. PCC is down. What will happen? PCC is down. Means A, B will communicate, but A, B, D won't communicate. E won't communicate because of the path will be like that. If wire is broken, anywhere wire is broken, so further communication will be stopped. So that is the point here. in the ring topologies. It's I didn't put in a proper hexagon type. If you want, I will put it.
Sir, if PCE down, then PCA, B, C, and D, and A, right?
Yeah, PCD down, A, B, C, E, A, B, C communicate. Okay,
No,
for reverse communication, C to
I am
E won't
asking
communicate.
okay.
And parallelly, there is a one more is there. What is that one? Double ring topology means double lines. Means A, B, C, D, E, A, one line. A, E, D, C, B, A, another line. So two lines they will put it and create as a double ring topology. So double ring topology, if in case C is down, so A, B, D communication is stopped, but still we can able to communicate with the reverse ring also, like a two-way type. It's a half duplex communication type, so that is full duplex type. Okay, double ring. So put another two more lines, then it is become double ring topologies. It difficult. It is works based on the ring related algorithms, but difficult to scaling means you can add more devices. Again, reconfiguration is required. If line is down, PC is down, further communication will stop. More number of devices from one device to another device, communication is become difficult. Okay. And I don't know why this is scroll up and down part is not working. It's okay. We'll put it one more line here. Later, next one is I will try in separate way. Again, Control C. Okay. So this one is also we don't use arrows, but this is kind of stuff like this. Anyone guess what is this topology?
Start.
Sir, start of
Very good, very good.
The interconnection of network from each and one to each other.
It is a connection of one PC to every PC. Very good. Yeah, but point is correct, but problem is it is not a star topology. It is a mesh topology. Okay. So when you see a star, so immediately what is the things comes into your mind? Sir, it is a star topology, right? Immediately star will come into the mind. It is not star topology, guys. It is a mesh topology. Okay. You have a PCs like a PC is there, BPC, CPC, DPC, and EPC. So A, B, C, D, E are connected. A is connected to B, C, D, E. E is connected to A, B, C, D. Okay, it is a most reliable network. It is a most reliable network. Why? Because of if A is down, no problem. Remaining devices will communicate each other. So no further communication device stopping is not there here. In a ring and bus topology, further communications, the one path communications are down. But here it is, one device is down, still remaining devices will communicate each other. One line is down, only that line is won't communicate, means A to B line is down, the wire is down. Okay, the line is down, but remaining communication is going on, right? A is able to communicate others, B is communicated to others. A to B direct communication is not there. Okay, so it is a more reliable, very complex, very difficult to troubleshoot, and no scalability. What is scalability, guys? Scalability means ability to increase the size of topology. We can't able to increase. It's a very difficult to scalability. Like if you add one more PC again, you have to insert a new NIC to each and every device, and we start giving cables. So that is a big headache, right? That is a big headache. So like a difficult to scalable, it's reliable, okay, and it provide a redundancy. One second, what is this? I got a notification. Okay. One second. Okay, so this is about here mesh topology, ring topology, and bus topologies. Okay, mesh topology reliable, complex, difficult to troubleshoot, difficult to scalable. Where we use the mesh topology, guys? Mesh topology used at servers, where we use more redundancy wise servers. Like if one server is down, one server is down. Okay, so for example, I will tell this one once I click and save. Okay, so yeah, good. Okay. A good thing it is. I'll go to this to explain small part here, guys. Look at here. This is a server and this is a client. This server, we are accessing some server. For example, this is a web server and it is giving some website. So I'm accessing a website from web server. Good, right? Now what happened? This server is down. Then what happened to the website? Can't able to access website. Server down, service down. Okay. Understand point? Server down, service will be down. Now what I have done? I put a more servers. Instead of one server, I put a more servers and make it as a one single unit. Okay. You're accessing a website from here. You're accessing a website. Now what happened? One server is down. No problem. Other server will give you a service. Okay. Even server is down, still you are able to access service. How? When the server is down, other server will give you the service immediately. Okay. So this is called a failover or high availability. This concept is called a redundancy, means backup kind of stuff. Not exactly backup concepts. Backup concept. It is a redundancy means immediately it can able to switch. So you need to wait for repairing, troubleshooting kind of stuff. When server is done, immediately other server is available. It will provide a service to you. Like inverter. Do you know inverter, right? In a home, electricity inverter, UPS. UPS. When power is down, UPS is up. Okay. When automatically up, right? So similarly, just for our understanding, redundancy, high availability, or a failover, these are all comes under this point. Okay. So where we need a more redundancy for places, there we use mesh topologies also there. Okay. Core router part or servers related SAN storages. We use this mesh topology. Okay. So SAN type of storage area network is there. No, SAN storage is also we use mesh topology. Guys, got the point? 1, 2, 3.
Yes, sir.
So last one, or this one. This is the actually star topology I'm trying to draw. So this one can be a hub or can be a switch. Okay, there is a hub or a switch. Okay, this is the hub or a switch. Okay, so like this, the devices will connected to this hub or a switch. Okay, hub or a switch, the devices will connect directly and form a network. So for example, this is PCA, PCB, PCC, PCD, PCE. All these PCs are communicating through this bus switch. What is the advantage? The advantage is what is the advantage, guys? What is the advantage is if PCD is down, no problem, remaining PCs will communicate each other. For example, this cable is down, no problem, remaining devices will communicate each other. So it is, but okay. So for example, you take a bus topology, a cable is down and the further communication is down. In ring topology, one PC is down, further communication will stop, or one cable is down, further communication is stop. But in a star topology, it is a simple to configure, but we are using a additional device here. In previous three topologies, we don't use any additional device. We use NICs and the cables only. But here we use a centralized device. Either it can be a hub type device or a switch device it is. Okay, device name can be hub or a switch we are using to create this star topology. It is simple to configure, simple to troubleshoot. It is easy to configure, easy to troubleshoot, and easy to scalable. Easy to scalable, but no redundancy. Why? Because of if this switch is failed, entire communication will be stopped. Okay. If one device is down, means PCA is down, no problem. Remaining PCs will communicate each other. Or a cable is down, no problem. Remaining devices will communicate each other. But the centralized device is down, entire communication will stop. But it is very easy to configure and we are using additional device and there is very easy to troubleshoot how it is. There is if we are using hub array which contains LED lights, that LED indicates the connectivity. So immediately we can understand where is the connectivity. Is a connectivity problem or device problem? So we can understand from that one we can troubleshoot very easily. But it is not much redundant. Why? Because of the centralized device down, everything is down. I said it is a scalable. Scalable. Scalable means in the sense, for example, I have a another small network, like I have a so many devices are there, but my switch having a okay. So this is another network, and I have a multiple devices. My switch having a limited ports, but all these devices I want to make them to communicate. What I have done, very simple. I connect this switch to this switch or this hub to this hub. Then obviously, okay, we can be a hub. Okay, see now this is entirely become one single network. So I can put any name like here it is PC1 A B C D E F. Okay, it can be FPC just for our understanding on E F G. Now all these devices can communicate each other. It is just extension of topology, guys, not a new network. Initially, this is a one network segment. This is another segment. Now both are become single segment only. Okay, so this is extended star topology. This is extended star topology. Okay. This is now become psycho again. Okay. So this is, guys, understand what is extended star topology?
Yes, sir.
But this is making me crazy now. It is not created at all. Okay, so understand matter. So leave it there because I already just yesterday revised. But if I keep putting into concentrating on into that one only, means it is waste of time. Okay, this is the extended start topology. Guys, point to point does not mean different things. Okay, point to point means a PC or a device are connected together directly. That is a point to point only. But originally, point to point word we use for whenever a router to router is directly connected through a serial connectivity, that is called a point to point. Mostly point to point word we used in WAN connectivity. Okay, point to point we use in a WAN connectivity. The WAN connectivity symbol is like this. This is a original point to point connectivity. Point to multi point connectivity means, dish TVs are connecting satellites. Okay, so that is a point to multi point connectivity is also there. But in our places we use One device is connected to multiple devices, like a switch is connected to multiple devices, right? That is also point to point, or one router is connected to multiple routers. In generally, if for example, if you take as a simple network, this is a one home network. Okay, someone's home network it is, or office network. Okay, this is another network. This is another. Why off of? Because you are in your network, you have your laptop, desktop, everything, okay, connected through this router. So one single router it is. So connected through this router. The router is connected to outside one router is there. In your area, there is a ISPs related router is there. Like that, different people are connecting from their router to this central router. Again, this router is connected to another router. Again, that areas. Like finally, they reach ISP's router. Okay, finally they reach ISP's. From ISP, again it will go outside. Like it will network will be bigger. Okay, small unit. I have my own network. Neighbor is having some other network. There are also some network. But those who are same subscriber, like Airtel people, so near to me. So there are all with individual connectivities. They will connect it to one central connect, and this is connected to another one. Like that, so many connections to go to very big core network. That is go to connected to other routers, which is outside kind of stuff. Okay. So that is point to point, multi-point, the kind of stuff. This is also example for point to point, multi-point. This is a tree topology. Tree topology is actually having a backbone wire. Okay, there is a backbone wire. So all these remaining topologies like a star topology or as direct PCs are connected to this one only. It is look like a branch or a stem is connected to multiple branches. So that's why it is called as a tree topology. So don't worry. Even this is also not required to put it. Actually, I can able to copy this one directly. This is enough. Okay, guys, this is about your topologies, but also read about a topology.
Sir,
Okay. Limited.
sir, in the 4 to 5 topology, which is most efficient topology?
We are all using star topology. Okay, we are all using star topology.
Sir, star topology usually in general way?
Yeah, we are all using star topology.
Okay, sir.
Sir, we use a star topology or the extended star?
Star topology or
Sir, or the extended star topology. You have explained both of them, no?
yeah, star and extended are in inside a star only type, right? Star means one star. Extended star means one star is connected to another star. Depends upon number of devices in your network.
Okay, sir.
Okay. For example, I have a switch. It is a 24 port switch. 24 port switch, big network. 24 switch. I have a 20 computers, single star. I have a 40 computers. Two switches are required. I have a 50 computers. Three switches are required. I have a 100 computers. Maybe at least 5 switches are required. So like that. Okay. So depends upon number of devices. So generally we are using star topology only. Then where we use a mesh topology, the mesh topology we use um, mesh topologies generally we use it as in a server redundancy purposes, core routing places, core routers places like this. guys, this is my router, which is got internet from outside. It is they're having some WAN connectivity. If it is a wireless devices are there, directly you can connect it to your Wi-Fi router. But there is a wired devices in my office. So what happened? There is a LAN connector. This is connected to this switch, one port. So these are the 24 port switches. Now devices connected to this switch will get internet. Now what I have done, I have connected from here to here. Now what happened? Devices connected to this switch also will get internet now. That is my extended star towel. Initially one star, now it is extended star. Now what happened? I connected another wire from here to here. Now this switch, those devices connected to these switches will get a internet from there. Okay. So now it is my network become very bigger by connecting. Okay. So always you have to think. See, two ports are, one port is internet purpose, one other port is connected to another switch. Here two ports are, one port for connecting to this switch, another port is connecting to this switch. Okay, this is only one port is utilized. Okay, like that. So if you have a 24 port switch, think about a 20 devices only. 4 ports, out of 4 ports, 1 or 2 ports we have to give it for connectivity to other switches or routers. Another 2 ports just for any choice, any chance we have to use it. Okay, and these are the things. Point to point, multi-point kind of stuff, tree topology kind of stuff is there. Next one is voice layer and IP addresses, guys. So take a small break and come back in 10 minutes. Okay, I'm in a home only, so I don't spend more time, but time is not there. That's why I connected very early today. So now it is 11:40. When will be back? 11:50. Okay. 10-15 minutes. 55 is also okay, no problem. Okay. Have a tea. Be energetic, guys. You are earlier initial days. You are very good, but now people are not at all speaking. Now you are asking questions. That is good thing. Okay. Still you have to do more.